Welcome to Module 3, the Software Testing Lifecycle or STLC. In the Module 2, we looked at the Software Development Lifecycle, which was about the lifecycle of building software. Now we zoom into our world. The STLC is the testing equivalent, a structured step-by-step process that defines exactly how testing is planned, designed, executed, and closed. So many beginners think that testing is just running the application and finding bugs. But STLC will show you that professional testing is a disciplined process which has defined stages, entry exit criteria, and concrete deliverables. This is that module that will turn someone from an app clicker into a QA professional. So if you're walking into a QA interview and you can clearly explain the 7 stages of STLC with the entry criteria, exit criteria and deliverables, you will immediately stand out. And this is the foundational knowledge that interviewers expect from people who are willing to join software testing. So this slide is sort of bridging the software development life cycle and software testing life cycle. So before we dive into the stages, let's clear up common confusion, the difference between these two. They sound similar and they're related, but they're not the same thing. SDLC is like a big umbrella, the full life cycle of building software from requirements to maintenance. We have covered this in our previous module. STLC is a subset. It focuses purely on the testing objectives. Think of it, the details zoom in on what happens during the testing phase of the STLC. Now, if the STLC is the process of building an entire car, design, manufacturing, assembly, delivery, then STLC is specifically the quality inspection process. How every part and the finished car gets checked, tested and signed off. Notice I said that STLC happens during and around the testing phase. As we learned with the early testing principle, the shift left testing that we talked about in the first module, STLC activities like requirement analysis, test planning, they actually begin much earlier while developers are actually coding. The STLC is not confined to one slot at the end. You might be asked about the difference between SDLC and STLC, and it is one of the most frequently asked QA interview question. So everything you see on the slide is like a roadmap. So here are the 7 stages of STLC. We are going to walk through each one in detail, but I want you to see the full journey first. Requirement analysis is understanding what we are testing and confirming if it is testable. Test planning is deciding the strategy, the scope, the resources, schedule and tools. Test case development is writing the actual test cases and the test data. Then there's environment setup where you prepare the hardware software where testing will actually happen. Then comes test execution where we run the test cases and record our results. Within defect reporting, we log, we track and manage the bugs that we find. And finally, it's the test closure where we wrap up, report the metrics and capture the lessons learned. So each stage has an entry criteria, which means what must be ready before the stage can start. And there's an exit criteria, which is what must be complete before we move to the next stage. So this is what makes STLC a disciplined process rather than an ad hoc activity. I'll point this out as we go further in this module. In Agile, these stages compress and overlap heavily within each sprint. But remember, the logical sequence still holds. If you understand these stages in order, it will make it easy for you to understand them when they are actually happening in parallel in the real world. So the first stage of testing happens before a single test is written, and it's about understanding what we are going to test. The testers read and analyze the requirement document, the software requirement specifications, user stories, the use cases. You can ask critical questions like, is this requirement testable? A requirement like the system should be user friendly is not testable as written. How do you measure friendly? So we push it back and get it quantified. We have to identify the ambiguities and raise them early because this is the cheapest point to catch a defect. Remember the cost of defects principle that we read in the first module? Try to relate it here. Then you decide what types of testing are needed, uh, be it performance, functional, security, usability, compatibility, to try to identify what all we would require. Then we begin assessing what can be automated. There's a key term called RTM, or the requirement traceability matrix, that you can see, which is a crucial document. This RTM maps each requirement to the test case that can verify it. It makes sure there's 100% test coverage. Every requirement has at least one test, and no test exists without a requirement mapping. So interviewers love asking about the RTM. Then the entry and the exit criteria. Entry criteria is the requirement documents must be available, stakeholder must be reachable for clarification. Exit criteria could be a signed off list of testable requirements and the start of the RDM. So in Agile, this happens during backlog grooming and sprint planning. The testers, they sit in those meetings and analyze the user stories as they are refined. So the stage 2 is where the test lead or test manager creates the blueprint of the entire testing effort, the test plan. They try to decide the scope, what will be tested, and just as importantly, what will not be tested out of scope. Then there is test strategy or the approach, wherein we talk about what levels and type of testing, manual, automation, what will be the split. We decide on that. Then we go to effort estimation, how many person days, using techniques like work breakdown structure or test case point estimation. That is what we all do here. Then we talk about the tools. Test management tool, are we going to use Jira, test rails, Zephyr? We talk about automation tools like Selenium, Playwright, Cypress, defect tracking tools like Jira or Bugzilla. We also talk about resourcing in terms of identifying who would do what, team roles. And we make the schedules, the milestones and timelines are aligned with the dev schedule. Then we do the risk analysis about what could go wrong, maybe late code delivery, environment unavailability, and how can we handle it. So the test plan is typically authored by the test lead or the test manager. As a junior tester, you will contribute to it and work within it. So understanding the structure is pretty important. And the entry criteria for this stage could be requirement analysis should be done, and the exit criteria could be the test plan, the reviewed test plan approved and signed off by the stakeholders. So be able to name the key sections of test plan and explain the difference between a test plan and a test strategy is a common interview question that you might come across. So now we get hands-on. Stage 3 is where we actually write the test cases, the detailed step-by-step instructions that describe exactly what to test and what result to expect. So a good test case has a test case ID or a title, preconditions, test steps, test data, expected results, the actual result, which is generally filled during the execution, the status, either it is pass or fail. So we can use, among the different test case designing techniques that are available, one of the example is equivalence partitioning, where we group inputs into classes and we test one input from those classes. So for example, your form, it accepts minimum 6 to maximum 12 characters. Then maybe we might identify classes as 0 to 5, 6 to 12, 13 plus or greater than 13. So within 0 to 5 we'll pick up one value, within 6 to 12 we'll pick up another, and 13 plus we'll pick up the third value. That's how we are creating partitions and using the different values. Then there is boundary value analysis, where we are testing at the edges, minimum, maximum, just inside, just outside. So suppose The age field takes 18 to 60 as the age. So we'll test at 17, 18, maybe 19, then 59, 60, 61 at the edges, min max, just inside, just outside. Then there are decision tables, which is generally used for complex business rules with multiple conditions. There is state transition, wherein if a system has different states, that's where you can use it to design your test cases. So these techniques let us achieve maximum coverage with the minimum number of test cases. And directly applying the exhaustive testing is impossible principle from module 1. Then there's test data. Test cases need data to run against. So we try to prepare realistic test data, valid, invalid, boundary, edge case data, which is all a part of this stage. Then there are peer reviews. So good teams peer review test cases before they're baselined. A second pair of eyes catches missing scenarios and unclear steps for sure. And this entry criteria is approved test plan from the previous stage, and exit criteria can be test cases and test data reviewed, approved, and baseline. Stage 4 is where we prepare the place where testing will actually happen. The test environment is a setup that mimics the real production environment as closely as possible. So hardware, servers, operating system, browsers, database with appropriate test data, network configuration, integration with other system or third-party services, which are generally mocked or stubbed. The application build deployed and ready is something that is generally involved here. Notice the stage can run in parallel with the test case development as well. When the testers are writing the test cases, the environment team or the DevOps can be setting up the environment. So the STL stages are logically sequential, but practically they overlap. So generally, sometimes QA sets this up in larger organizations. There are dedicated teams, DevOps team that set up the test environment. Either way, the tester will verify that the environment is ready. Then there's smoke testing, which is the readiness check that happens in the test environment setup. So once the environment is set up and the build is deployed, we run a smoke test, a small set of critical test cases to confirm the environment is stable to begin real testing. Now, if the smoke test fails, testing will not start, and it will save us from wasting efforts on testing on a broken setup. So environment issues are generally one of the biggest causes of testing delays in the industry. Wrong configurations, missing test data, unavailable integration. They create a project risk, and these might delay your deliverables. So for test environment setup, the entry point is the readiness of test plan and system design, and exit criteria is generally the environment ready and the smoke test passes. Then we come to stage 5, which is the heart of the action, test execution. And this is what most people picture when they think of testing, actually running the test cases against the application. So within the execution process, you run each test case step by step manually or trigger the automation suite. You observe the actual result, compare it to the expected result, and document the outcome. You either mark the outcome as pass, fail, or blocked. Pass is when it matches the actual expectation, the actual matches the expectation. Fail is where the actual differs from expectation. This is where we raise a defect or a bug. And the blocked is where you could not run the test, maybe because a prerequisite feature is broken. So when a test fails, you immediately log a defect with all the details needed to reproduce it. We'll be covering exactly how to write a great bug report in the deliverables section later. There comes two important terms here, retest and regression. So retest is once a developer fixes a bug, you rerun that specific test to confirm that the fix works. Regression is running a broader set of tests to ensure that the fix did not break anything else. There are execution cycles that usually happen. Like these executions are happening in cycles or rounds. In the cycle one, maybe you will run everything, find bugs, dev will fix. There would be another cycle, you will be retesting, you will be doing some regression, and this will repeat until the exit criteria is met. So this is where you track the pass-fail rates, the defect count, and the test execution process. The data that feeds into your final test summary report is what you gather from the test execution. The entry criteria for test execution is the environment readiness, test cases baseline, and smoke testing passed. And the exit criteria are the planned test executed, results and defect recorded. Now we come to the stage 6, which runs hand in hand with the execution. Finding a bug is only half the job. Communicating it clearly so it gets fixed is the other half. A poorly written bug report is a bug that will never get fixed. Now the defect life cycle ideally is new. From new it go to assigned, then it goes to open, fixed, you retest it and you close it. So there are branches to it like rejected, deferred, duplicate or reopened. Every defect moves through a life cycle, and as a tester you open it, the dev fixes it, you retest it, you close it, or you reopen it if the fix did not work. For the bugs, we assign severity and priority. And guys, this is an important interview topic. Severity is the impact on the system, how badly it will break the things. It is generally set by QA. It could be critical, major, minor, or cosmetic. And there is priority, which is how urgently should this be fixed. So this is generally set by the business or the project manager, and generally marked by high, medium, low. So these severity and priority are independent. A spelling mistake on the company logo on the home page is low severity because it is not impacting any functionality or the overall feature. But it is of high priority, it is cosmetic, but embarrassing and must be fixed fast. On the other hand, a crash in a rarely used admin screen might be high severity because the feature is being impacted, but low priority because it is not used in that much frequency. If you master this distinction, it will help you a lot because this question comes up in almost every QA interview. Now, what is a bug report? So bug report is ideally a deliverable that comes out of execution. A bug report has a clear title. There are steps to reproduce as to how you got onto that bug, the expected versus actual outcome. There are screenshots, logs, maybe test data, environment details, severity, and priority. So you document everything and share with the developers. So tracking defect trends ties back to the defect clustering principle from module 1. Remember, we talked about how 80/20 is the overall analytics, or how bugs are generally they are clustered in one area. So the data tells you which module are buggiest, the defect clustering data, and you can focus all your effort there or most of your effort there. So for defect reporting and tracking, the entry criteria should be that test execution is underway, and the exit criteria is that all defects are getting logged, tracked and resolved or formally deferred. Then we come to the last stage, the test closure stage, and this is the stage beginners most often skip. It is how we formally conclude testing and capture value for the future. So you confirm all the exit criteria are met. Are the critical defects resolved? Is the coverage expected or the acceptable coverage is achieved? Then you prepare the test summary report, the headline document summarizing the entire testing effort. Then you analyze the metrics like the test coverage percentage, the requirements that you have covered, the defect density in terms of defects per module, the pass and fail rate, the defect leakage, what you have learned from your previous release, what went well, what did not, and what do you have to improve. This is the retrospective mindset that we were talking about. You archive the data, like you store the test cases, scripts, data, and reports so that they can be reused in future cycles and releases. So closure turns the testing cycle into organizational knowledge. The metrics justify QA's value to management. The lessons learned make the next cycle smoother. The archive testware saves huge amount on the next release. If you skip closure, it means every cycle starts from scratch and you can never prove your impact. The closure activities, they feed the final go or no go release decision. Testing provides the information, stakeholders make the call. So for test closure, the entry criteria is that the test execution completes, and the exit criteria is that the test summary report signed off, cycle formally closed. So once all these stages are done, we are all good to go. Now we walked through the 7 stages. Let's talk about the tangible outputs from STLC, the deliverables. These are the documents that survive after the testing is done. They prove the work was done, communicate quality to stakeholders, and also guide future testing. So, there are 4 core deliverables you absolutely must know. There's test plan, test cases, bug report, and test summary report. And each of this is produced at a different STLC point, and each serves a distinct audience and purpose. So if the 7 stages are the verbs of testing, the actions, then these deliverables are the nouns, the artifacts you produce and that you hand over. So the test plan is the master document, the blueprint of the whole testing effort. It is created during the second stage, the test planning stage, and generally owned by the test lead or manager. We have key sections like scope, what is in scope and what is out of scope, the test strategy or the approach, wherein we talk about the levels and type of testing, manual or automated. Then there is schedule and milestones, the timelines align with the dev plan. There are resources and roles, who's on the team and who does what, tool and environment, what software and setup we'll be using, entry and exit criteria, conditions to start and to stop testing, risk and mitigation, what could derail testing, and what would be our backup plan. So there's an IEEE 829 standard that defines a formal test plan structure if you ever need a reference. But most companies have their own template based on these 4 sections. Then we have the test cases, which are the detailed, repeatable instructions for verifying the functionality. They are created in the third stage. A good test case is so clear that any tester, even if they are new to the project, they can execute and get the same result. So test case has an ID and title, which is a unique identifier and a descriptive name. There are some preconditions as to what must be true before we start with our steps. For example, the user must be logged in. Then there are test steps, the numbered specific actions. There is test data, the exact inputs to use. There is expected result, as in what should happen, the actual result, what actually happened, and the final status, pass, fail, or blocked. So a test case example could be maybe verify login with valid credentials. Precondition could be user account should be present. The steps could be open login page, enter valid email, enter valid password, click login. The expected is user lands on the dashboard. And this is a complete executable test case. Once you execute it, you will confirm if it actually passes or fails. Now there are test cases and you will come across test scenarios as well. A scenario is generally a high level what to test, and a test case is detailed how to test it with steps and data. And interviewers generally ask difference between test case and test scenario, and you can identify through the depth of information one has. Scenario is high level. Next, we come to bug reports. So a bug report is your primary communication tool with the developers. I cannot overstate this. The quality of your bug report, it determines whether and how fast a bug gets fixed. A great bug report lets a developer reproduce the issue without talking to you. If they have to come ask, how did you get this? It means the report was not good enough. So some of the essential fields in a bug report are defect ID and summary, which is generally a crisp one-line title. Maybe something like checkout fails with 500 error when cart has more than 10 items. The steps to reproduce will have numbered exact repeatable steps. Expected versus actual is what should happen versus what actually did. Severity and priority, the distinction that we just discussed about. Screenshots, log, video, some visual proof or technical detail. The environment details, the browser, the operating system, build version, device. Then the status and assignee is where it is in the life cycle and who's the owner at that specific stage. So a bad title for a bug could be login broken, but a good title could be login fails with valid credential on Safari 17, returns blank page instead of dashboard. A good detailed information about it. Then there is test summary report. So this test summary report is the capstone deliverable produced during the test closure. It's written for stakeholders and management, often people who are not technical. It answers one big question: is the software ready to ship? So a test summary report ideally has scope and objectives of testing. There are test plan versus actually executed. Then there is the pass fail blocked breakdown. There's defects by severity as to how many are critical, major, minor, what all are open, the test coverage that we have achieved, the outstanding risk and deferred defects, and the go no go recommendation. And this is where QA demonstrates its value. Good metrics in a clear summary report can show management exactly what the testing effort accomplished and give them the information to make the release decision. Remember, we provide the information, but the stakeholders make the call. Now let's bring it all together. Here's the entire STLC in one picture. Each stage on the left and the concrete deliverable you see on the right. Notice how each output becomes the input for the next stage. Try to recall all the 7 stages that we have talked about, and if you can do that, you have genuinely understood this module. So to reinforce what we have studied or what we have gone through, requirement analysis gives us testable requirements which feed the test plan, which guides the test case development, which would need an environment to run in, which enables execution, which surfaces defects, which all get summarized at the closure. It's a chain. Break one link and the whole process suffers. This STLC sits inside the testing phase of the SDLC we covered in our previous module, and the principles we test by from the first module apply throughout. So the series builds on itself. So let's lock in what we covered in module 3. This STLC is a 7-stage structured process starting from requirement analysis, test planning, test case development, environment setup, test execution, defect reporting, and test closure. The entry and exit criteria at each stage make testing a disciplined and measurable process. STLC sits inside STLC but is purely about testing and quality. There are 4 deliverables that you must know: test plan, test cases, bug reports, and test summary reports. Their severity and priority, and the art of great bug report is about writing all the steps and the details so that the developer need not come back to you and ask what the bug is all about. So if this helped you understand how professional testing actually works, hit subscribe, share this with anyone preparing for QA interviews because the STLC is interview gold. And drop your questions below. What part of STLC do you want me to go deeper on? Your comments shape this series. Thank you for watching. See you in module 4. Keep learning, keep testing, and remember, a structured tester is a valuable tester.